So, hello guys, good afternoon. So let's quickly talk about work. Now, work is said to be done. Work is said to be done whenever a force is applied to something and a distance is moved in the direction of the force. Note, whether distance is not moved or the distance moved is not in the direction of the force, then work is not done. Maybe you are applying the force in this direction and you move a distance on this direction, work is not done. Take note, work is not done on that body. Are we together? So the distance, number one, the distance must be moved. Number two, the distance moved must be in the direction of the force for work to be done. Take note of that. So now, the work done is a scalar quantity. And don't forget, you can go and watch my video on vector. Whenever you have scalar quantity, yeah, that's dot product. So work done because that's vector f dot what? Vector s, where s is the displacement. Work done is not force times distance. There is nothing like force times distance in physics. It's force times displacement. Take note of that. So this vector f dot vector s, that's work done. Or in another form, you can say your work done equals to magnitude of f, magnitude of x, cos what? Cos theta. Where theta is the angle between the force and the displacement. Theta is the angle between the force and the displacement. And in analytical form, we can say our work done equals to what? Fx Sx plus what? Fy Sy plus what? Fz Sz plus, depending on how many dimensions you have, like adding everything together to give you the total work done on a body. We get. And if the force is not constant over a displacement or over a distance, if force is not constant over a distance, you are to get your work done now, you are doing a lot of addition, a continuous addition, because as you are applying the force, the distance is changing. So to get the work done to get the total work done, you are going to add all the work done at each point. And in the course of doing that, you are integrating. It's going to give you integral of f dx for lower limit of x1 to upper limit of x2. So you can also apply it to this analytical form. If it's like this, it can be plus what? F dy, fx dx, fy dy plus fz. Yeah, this will be x2 plus integral of y1 y2 plus integral of z1 z2 z. It also have multiple force like applied on each axis and distance move on each axis. You can integrate each and add them together. So this case is you deal with this case whenever you have something like this. If your force is written in form of, maybe we are given 2xi plus 3yj. So whenever you have your force written in this form, just take note that the force is not constant over a distance. Are we together? So in this course, you are going to integrate. But if the force is written like this, 2i plus 3j, just do your dot product directly like this or something like this to get your work done. So that's that. But this one, to get your work done, you are integrating. So take note of that. Now let's have a few questions before we move on. So let's say here we have a body moves through a distance of 5i through a distance of 5i plus 2j minus 5i plus 2j minus 3k from the origin 0,0,0 under the influence of a constant force F equals to 4i plus 3j minus 2k. Now find the work done and the angle between S and F. Now we have been given displacement already. Displacement is something like the distance you moved through. Are we together? Like in this course, in this sense, because this is a straight line. The only time you have displacement to be equal to distance moved is when the motion is on a straight line. So here it's like a straight line. So since it moves through the distance, that's also our displacement. So regardless whether it's starting from the origin or not, we are still going to use this. Assuming it's not even starting from the origin, maybe we have comma 1, comma 2, comma 3. You have nothing to do with this because what? The displacement has been given already. Work done is first time displacement. So you have been given the displacement already. But if you are not given the displacement and the body moves from this point to another point, maybe to another point, let's say this x, y, z, to another 1, 1, 1, let's say x2, y2, z2, to another point 4, 5, 6. In this course now, you need your displacement. So what are you going to do now? You subtract this like 4i plus 5j plus 6k. This like 1i plus 2j plus 3k. So you subtract the two to get the distance that was being moved, to get the displacement. So now your s here, now your vector is going to give you 4i minus I, that's 3i, 5j minus 2j, that's 3j, 6k minus 3k, that's 3k. So this is the displacement you are going to use, that you are going to dot with the force to get your work done. But in this case, whether the initial point is origin or it's not even origin, maybe it's not even origin, maybe it's at this point. But since you have been given displacement already, so you don't need to be subtracting this from this. The subtraction we did earlier is already given in this form. So this is given already. So whether this is from the origin or not, you will still get the same answer because we don't need this in our calculation. We have been given displacement already. So now let's find our work done. Work done is equals to what? We are dotting this together. So 5i times 4i, that's 20i squared. I can only do 5 times 4, which is 20, because I squared is just 1 under dot product. I times I, that's just 1 under dot product. Whenever they are moving, how can I put it now? They are moving under the same, when the direction are the same thing. For instance, because this is I direction, this is also I direction. That means the angle between them is 0. What's cos 0? Cos 0 is what? Cos 0 is 1. Are we together? So whenever you have the same direction, if you multiply them together, it gives you what? It gives you 1. So you don't need to write 20i squared. Don't bother yourself because I squared itself is just 1. So plus 2 times 3, that's 6. Minus 3 times minus 2, that's also 6. So this one gives us what? 32 joules. Equals to 32 joules. That's our work done. Now to get the angle between them, we are going to find the magnitude of S and the magnitude of F. Now F magnitude equals to square root the quotient of IS square it plus the quotient of JN square it plus the quotient of KN square it, and that gives us a root of 16 plus 9, that's 25, plus 4, that's 29. So this gives us what? Root of 29. So that's our magnitude of force. Now the magnitude of the, don't forget our work done is 32 joules. The magnitude of the displacement is equal to what? Square root of 5 square plus what? 2 square plus what? Minus 3 square. 25 plus 4, that's 29. 29 plus 9. That should be 38. So this gives us root of what? 38. Don't forget the initial formula it gave us that. Work done can also be written as what? The fact that it is this, which we did there, like it's also equal to something like this. So it depends on what you are looking for that determine what you are going to use. We use this method to find our work initially. So we are using this one to find the angle. So since our work done is 32 joules, because what's magnitude of F? Root 29. What's magnitude of X? Root 38. Cos what? Cos theta. Now make cos theta the square root of the formula. You're having what? Cos theta equals to what? 32 over what? Root 29 times root 38. Now theta will give us what? Cos inverse. That's half cos of what? 32 over what? Root 29 times what? Root 38. Degree. Just punch your calculator and get your angle. So the angle here is the angle between F and S. So that's that for that. Now let's treat one more question or two, then let's call it off. So now the second question, down that deals with integration. If you are given a force, F equals to 4xi plus 3yg, act on an object as the object moves in the x direction from the origin to, we are given x1 is from the origin 0 meter to 5 meter. Now find the work done on the object by this force. Now, because we are having variable x and y, that means the force is not constant over this displacement. Are we together? So in this case, as long as it's just I and j, do your dot product, but you are saying x and y. This time we are integrating, take note of the difference. Now, but because there's no distance move along the y-axis, the work done along the y-axis is 0. So we are not integrating this, we are only integrating x. So integral of what? 4x dx. Lower limit of 0, upper limit of 5. So if you integrate 4x, you get 4x over 2, 0, 5. 2 here 1, 2 here 2. That's what? 2s squared, 0, 5. Substitute 5, you have 2 into what? 5 square minus substitute 0, you have 2 into what? 0 square. And that's what? 2 times this 5 square, that's 25. That's what? 50 joules. But assuming there's a distance move here, we also do it like this and add the two together to get your answer. So that's that for that. There's no. So thanks for watching. Don't forget to like and subscribe. See you in the next video.